I welcome you to this discussion where we're looking at simple harmonic motion. With me, I have a question which states the time period of a simple pendulum at a place where the acceleration due to gravity g is t. So if you are given that the time period of a simple pendulum and at a place where the acceleration due to gravity is given as g, then its period will be t. So if this is given, what will be its time period at a place where the acceleration due to gravity is 1.02 of g? So let's find our new period. Now with this said, let's look at our solution. So we are now looking at the solution to this problem. Alright, so now for a simple pendulum, what we have is that the period for a simple pendulum, the time period for a simple pendulum is simply given as t equals to 2 pi multiplied by the root of the length divided by acceleration due to gravity. Okay, so this that we have is simply the time period when the acceleration due to gravity is g. That's based on what we have in the question. Now we are now told to simply find the time period when the acceleration due to gravity is 1.02 of g. So what we're going to do is we're going to use a different notation for the time period, which is t prime, and we'll let this to be the time period at a place where the acceleration due to gravity is 1.02 g. Okay, so our t prime represents this period at a place where acceleration due to gravity is 1.02 over g. So this is to say that t prime, which is our second period, is equals to 2 pi then root of, so the length is maintained, still the same one, then acceleration due to gravity is 1.02. so the acceleration due to gravity is 1.02, this one that we have in this expression, so 1.02 of g. Okay, so now what we are looking for is t prime, hence we're going to come up with an expression. So what we do is t prime is what we're looking for. So to know what t prime is, we'll come up with a relationship between t prime and t. So this is simply the way they can relate is simply coming up with the ratio of the two. So t and t prime can relate in form of a ratio, where we say that t prime, so this would be t prime divided by t. So what we now do is, while there's t prime, we substitute what we have, and this is simply what we have on top there. This is 2 pi multiplied by the root of L divided by 1.02 g. Okay, so this is a substitute for t prime. Then we say over what we have for t, which is the period at where acceleration due to gravity is g. So this is 2 pi, length is still the same, then we say over g. Now okay, 2 pi will go, so we have that t prime over t will be equal to the root of L over 1.02 g. Then I'll use this symbol to denote division, and root of L over G. So according to the laws of sets, what I'll simply do is I'll express this ratio as, for the roots I'll split them since they're dividing, so that the part on top to have its own root and also the part down to have its own root, like this. Then we say divided by, we do the same, so I have root of L divided by the root of G. Alright, so we proceed writing our ratio, which ends up being root of L. So for the part we have done, according to the laws, we can split 1.02 to have its own root and also G under its own root, like that. Then we say divided by, now we multiply, then G will go on top with its root, same as L, like this. G will cancel, L will also cancel. So what we have is that our ratio will be 1 divided by the square root of 1.02. So this therefore means that our ratio will be 0.99 upon computing this. So since it is t prime we're looking for, we make it subject to the formula. Hence we have t prime to be equal to 0.99t